You ever look out at the ocean and think, man, I'd love to put a house there? Imagine waking up to the sound of waves crashing, the endless horizon stretching out before you. Probably not the first thing that comes to mind. Most of us would think it's a crazy idea. Water, as beautiful and powerful as it is, doesn't exactly scream stable foundation. The constant motion, the sheer force of waves, it all seems too unpredictable. It's wet, it moves, and it's home to things that like to nibble on wood. Marine life can be quite the challenge for any structure, not ideal for your average basement. Water damage is a homeowner's nightmare, but humans, we're a stubborn bunch. We see obstacles as opportunities. We love a good challenge. It's in our nature to push boundaries and explore the impossible. And building on water? That's a challenge we've tackled head-on with some pretty amazing results, from oil rigs to floating homes. We've done it all. Think massive oil rigs, towering bridges, even whole cities built right on the water's edge. These feats of engineering are nothing short of miraculous. So how do we do it? How do we make the impossible possible? How do we defy gravity and the might of the ocean to put buildings where they seemingly shouldn't be? The answer lies in some ingenious engineering. The answer lies in a clever bit of engineering called pile foundations. These structures are designed to provide stability in the most unstable environments. These aren't your grandma's garden variety foundations. They're built to last and withstand the harshest conditions. We're talking about driving massive supports deep down into the seabed, creating a solid base that can withstand the toughest conditions. It's a marvel of modern engineering. It's a dirty job, no doubt, but someone's got to do it, and the results are worth every bit of effort. And trust me, the science behind it is pretty darn fascinating. It's a testament to human ingenuity and our relentless pursuit of progress. All right, let's break it down. Pile foundations are like the unsung heroes of construction. They're the strong, silent type, holding up massive structures without a complaint. Essentially, they're long, slender columns driven deep into the ground, or in this case, the seabed, to transfer the load of a structure to a more stable layer. Think of it like this. You wouldn't build a house on a pile of marshmallows, right? You need something solid, something that won't budge. In water, that solid ground can be pretty far down. That's where piles come in. They act like giant nails, anchoring the structure to a more secure foundation. But it's not just about length. It's about choosing the right type of pile for the job, and believe me, there's a whole lot of options to choose from. Just like there's no one-size-fits-all solution for a good pair of work boots, there's no single type of pile foundation that works for every project. We've got timber piles, the old faithful of the bunch, great for lighter structures and often used in restoration projects. Then there are concrete piles, the heavy hitters known for their strength and durability, perfect for those massive bridges and offshore platforms. And let's not forget steel piles, the tough guys of the group, resistant to impact and corrosion, ideal for challenging environments. And if you're working with softer soils, screw piles are your go-to. These bad boys have helical blades that twist into the ground like a giant corkscrew. Talk about efficiency. Each type of pile has its own strengths and weaknesses, and choosing the right one depends on factors like soil conditions, load requirements, and even the project budget. Section 4. Engineering underwater. It's not easy being deep. Building on water isn't for the faint of heart. It requires a unique blend of engineering prowess, physical endurance, and mental fortitude. It's a whole different ballgame than building on dry land. The challenges are numerous and often unpredictable. For starters, you've got to deal with water pressure. This invisible force can be a formidable adversary. The deeper you go, the more the water pushes back. It's a relentless force that never takes a break. That means your piles need to be strong enough to withstand that constant pressure. They must be designed to endure the harshest conditions. And then there are the currents and waves. These natural elements can be both unpredictable and powerful. These can cause all sorts of problems, from erosion to vibration. Each issue requires a different solution. Engineers have to account for these forces when designing pile foundations, using sophisticated models and simulations to make sure the structure can handle whatever Mother Nature throws at it. It's a meticulous process that leaves no room for error. Oh, and let's not forget about the challenges of working underwater. The environment is often less than ideal. Visibility can be terrible, currents can be strong, and did I mention the marine life? Divers have to be constantly vigilant. It's not exactly a walk in the park. Every task is a test of skill and endurance. Specialized equipment and highly skilled divers are essential for tasks like underwater welding, concrete pouring, and inspecting the piles for any signs of damage. These professionals are the unsung heroes of underwater construction. It's a tough job, but somebody's got to do it. And those who do it with unmatched dedication and expertise. Section 5. Planning is key designing for strength and stability. Building on water is a bit like putting together a giant jigsaw puzzle. Only the pieces weigh tons and are submerged in water. Each piece must fit perfectly to ensure the structure's stability and strength. It all starts with understanding the ground below. The underwater soil and its characteristics are crucial for the foundation. Engineers use specialized equipment to conduct soil tests, figuring out what they're working with down there. These tests reveal the soil's composition, density, and other vital properties. This helps them determine the length, diameter, and type of piles needed to support the structure. The data collected is meticulously analyzed to ensure the right decisions are made. Next comes the design phase. Engineers create detailed 3D models and draft plans that will guide the construction process. This is where things get really technical. Every calculation must be precise to ensure the structure can withstand various forces. Engineers use complex calculations to figure out how much weight each pile can handle, how many piles are needed, and how they should be arranged to distribute the load evenly. This ensures the structure's stability and longevity. And we can't forget about installation. This phase is critical and requires precision and expertise. Driving those massive piles into the seabed is no easy feat. It demands powerful machinery and skilled operators. It requires specialized equipment like pile drivers, which use a heavy weight to hammer the piles into place. The precision of this process is vital for the structure's foundation. And in some cases, they even use vibratory hammers, which vibrate the piles into the ground. This method can be more efficient in certain soil conditions. It's a noisy, messy business, but hey, that's construction for you. Despite the challenges, the end result is a strong and stable structure that stands the test of time. Section 6. Standing tall. From oil rigs to floating wonders, pile foundations are the unsung heroes behind some of the most impressive structures on the planet. Take offshore oil platforms, for example. These behemoths of engineering stand tall in some of the most hostile environments on Earth, thanks in no small part to their sturdy pile foundations. Then there are floating bridges like the Evergreen Point Floating Bridge in Seattle. These marvels of modern engineering use pontoons to stay afloat, but they still rely on pile foundations to anchor them in place and provide stability. And let's not forget about piers, wharves, and even wind farms, all of which rely on pile foundations to stay put. From bustling harbors to towering wind turbines, pile foundations are essential for keeping our world connected and powered up. Section 7. The future is built on piles essential for a changing world. As our planet faces the challenges of climate change and rising sea levels, the importance of building sustainably and resiliently has never been greater. Pile foundations, with their versatility and adaptability, will undoubtedly play a crucial role in shaping the future of construction. From floating cities to offshore wind farms, these underwater supports offer a stable and reliable solution for building on water. So the next time you see a bridge stretching across a vast expanse of water or a towering structure rising from the ocean depths, take a moment to appreciate the hidden marvel of pile foundations. They're the unsung heroes holding it all together. Proof that with a little ingenuity and a whole lot of hard work, we can build just about anything, anywhere.